Welcome, AI enthusiasts. Today we delve into the world of TensorFlow, the open-source machine learning library developed by Google. This powerful tool is not just a library but a comprehensive ecosystem used for implementing machine learning and other computations involving large amounts of data. TensorFlow's primary purpose is to simplify the process of acquiring data, training models, serving predictions, and refining future results. It's a powerhouse for high-performance numerical computations used widely in the development of machine learning applications. This is all thanks to the flexibility and scalability it offers, enabling developers to build and deploy machine learning models with ease and efficiency. From voice and image recognition to pulling out insights from unstructured data, TensorFlow plays an integral role in driving the AI revolution. So, are you ready to dive into the world of TensorFlow? Let's get started. TensorFlow wasn't built in a day. Its journey and evolution have been quite remarkable. The brainchild of the Google Brain team, TensorFlow was born out of the need for a system that could build and train neural networks to detect and decipher patterns and correlations, somewhat akin to our human learning process. Released as an open-source software in November 2015, it was designed to run on multiple CPUs or GPUs, making it a go-to for many machine learning enthusiasts. Its flexibility, scalability, and incredible capacity to process large-scale data swiftly propelled it into popularity. Over the years, TensorFlow has grown and evolved, improving with each version. From its initial focus on deep neural networks, it has expanded to support a wide array of algorithms, making machine learning more accessible to everyone. That's a brief history of TensorFlow. Now let's get into how it actually works. At the heart of TensorFlow, there are some key concepts that you need to understand. Firstly, we have tensors. Tensors are multidimensional arrays of data, and they're the core data structure in TensorFlow. They are like the building blocks of everything we do in TensorFlow. From simple scalars to complex multidimensional matrices, all are represented as tensors. Next we have graphs. TensorFlow uses a data flow graph to represent your computation in terms of the dependencies between individual operations. This leads to efficient computation, and also makes it easier to compute derivatives, which are very important in machine learning. Then, we have layers. Layers are the basic building blocks of neural networks in TensorFlow. Each layer in a neural network does a specific job, and together, they extract features from data and make predictions. They're like the workers in the factory that is your neural network. And finally, we have modeling. Modeling is the process of defining the structure of your neural network. You decide how many layers you want, what type of layers you need, and how they should be connected. It's like designing the blueprint of a building. But it's not just about defining the model. Once you've got your model, you need to train it on your data. And that's where TensorFlow shines. It provides efficient and scalable methods for training complex models, using techniques like automatic differentiation and stochastic gradient descent. After training, you use your model to make predictions on new data. And again, TensorFlow makes this easy with its simple and intuitive API. You just feed in your data, and TensorFlow takes care of the rest. So, to summarize, tensors are the basic data structures, graphs represent computations, layers are the building blocks of neural networks, and modeling is the process of defining and training your neural network. And all of this is made easy with TensorFlow's powerful and flexible API. These concepts form the backbone of TensorFlow. But how do we set it up? Let's find out in the next scene. Before you start using TensorFlow, you need to set it up correctly. TensorFlow is an open-source library developed by Google and is utilized for high-performance numerical computations and machine learning applications. To install TensorFlow, you'll need to have Python installed on your system. You can use pip, Python's package installer, to install TensorFlow. Open your command line or terminal and type pip install TensorFlow. This command should download and install TensorFlow onto your system. After the installation, it's time to set up your environment. You'll be using Jupyter Notebooks, a web-based interactive computational environment for most of your work. To install Jupyter, you can use pip again. Just type pip install Jupyter in your command line or terminal. Finally, to confirm that TensorFlow has been installed correctly, you can run a simple command in your Python environment. Import TensorFlow as TF. If there's no error, congratulations. You've successfully installed TensorFlow and set up your environment. With TensorFlow installed, we're now ready to start performing some operations. Now that we have TensorFlow installed, let's use it for some basic operations. The first thing to know about TensorFlow is that it essentially operates on tensors. These are multi-dimensional arrays, similar to the arrays in NumPy, but with a few key differences. Tensors are designed to work well with GPU acceleration and distributed computing, making them an ideal choice for heavy numerical computations. Let's start with some basic mathematical operations. Say we want to add or multiply two tensors. We can create tensors using TensorFlow's built-in functions such as tf.constant and then use TensorFlow operations like tf.add or tf.multiply to perform these calculations. The result is a new tensor. Next, we'll dive into tensor manipulation. Tensors can be reshaped, transposed, and even split into multiple smaller tensors. For instance, the tf.reshape function allows us to change the shape of a tensor without changing its data. This is particularly useful when preparing data for certain types of machine learning models. Another important aspect of TensorFlow is the concept of variables. A variable is a type of tensor that holds mutable state. This means that its value can change over time, unlike a constant tensor. Variables are used, for example, for the weights and biases in a machine learning model. Finally, let's talk about basic operations. In TensorFlow, operations are nodes in a computation graph. When we perform an operation, we are actually creating a new node in this graph. This graph-based approach enables TensorFlow to perform complex computations efficiently and to automatically compute gradients, which are essential for optimizing machine learning models. In summary, TensorFlow provides a powerful and flexible platform for performing numerical computations. By using tensors, it allows us to easily perform a wide range of operations, from simple mathematical calculations to complex machine learning algorithms. Those were some basic operations. Now let's see how we can create models and layers with TensorFlow. Building models and adding layers, that's where TensorFlow really shines. To build a model in TensorFlow, we start with the sequential model API, a linear stack of layers. We then add layers to our model using the add method. Each layer is a different piece of the neural network puzzle, with its own unique role in the learning process. Now let's say we want to add a dense layer, a type of layer that connects each input to each output within its layer. We simply call model.add and specify dense as the layer type. We then specify the number of neurons in the layer and the activation function we want to use. Adding layers in TensorFlow is like building blocks. We stack them one on top of the other, each layer learning from the one before it. The result? A sophisticated and intelligent model ready to learn from your data. And that's how you build models and layers with TensorFlow. But what's next? Let's take a moment to recap what we've learned so far. TensorFlow, an open-source library developed by Google, has been designed for high-performance numerical computations and machine learning applications. Its importance in the field of artificial intelligence cannot be overstated, as it provides a comprehensive platform for creating and deploying machine learning models. We delved into the history and development of TensorFlow, tracing its path from inception to its current status as a popular tool in the AI world. We learned about its evolution and how it has adapted and grown to meet the ever-changing needs of the AI community. We also explored the core concepts of TensorFlow, such as tensors, graphs, and layers. Understanding these fundamental components is crucial to grasp the inner workings of TensorFlow and how it manages data and computations. We then discussed how to install TensorFlow and set up the environment. This step-by-step guide is intended to help you get started on your TensorFlow journey. Moving forward, we touched upon basic TensorFlow operations. We used practical examples to demonstrate how to perform simple mathematical calculations and tensor manipulations, giving you a taste of what you can achieve with TensorFlow. We also delved into TensorFlow models and layers. Here we learned how to construct models and add layers using TensorFlow, providing foundational knowledge for more complex model building. Moreover, we discussed how TensorFlow can be used to implement deep learning algorithms, and we introduced the concept of transfer learning. We explained how pre-trained models can be utilized and adapted for your own projects. Finally, we highlighted the importance of the TensorFlow community and resources, emphasizing the value of continuous learning and development. And that concludes our journey into the world of TensorFlow. Remember, the more you practice, the better you'll get, so start exploring.